In example 1, we need to find all of these different things: the cosine of 2 theta, sine of 2 theta, tangent of 2 theta. And then we're given some information up here about the cosine. We're also told that theta is between 0 and pi over 2, or 0 and 90, and we want to find the exact values. To do that, we're going to use some formulas. So if you haven't already, please utilize your trigonometric toolkit. And I want you to write down these half-angle identities. We're not going to be using any of that for this particular example, but the examples in this learning target or this objective will use these. Notice how the square root symbol goes all the way down and totally covers this 2. This fraction is all underneath this sign. The plus or minus means you need to choose whether or not the sine of the original angle or the cosine of the original angle or the tangent of the original angle is positive or negative. Also, and you can pause the video if that was too fast, I want you to write down these formulas. So we've got the sine of 2 theta here, the tangent of 2 theta here, and the basic cosine of 2 theta formula is cosine squared minus sine squared. That's different than the Pythagorean identity. Remember that the Pythagorean identity, cosine squared plus sine squared, is 1. Cosine squared minus sine squared then would definitely not be 1. It's cosine of 2 theta. If you use the Pythagorean identity though, and you substitute in for either one of these values, you're going to wind up with these. So sometimes these are useful. The cosine of 2 theta is equal to either one of these. Pause the video if you need to write those down, and if you forget them, you can look them up on the old internet. Alright, we're going to start then with this example, and I'm going to keep my trigonometric identities toolkit close to me so we can use those formulas. And so what we want to do here is we want to see how we can expand the cosine of 2 theta. If the cosine of theta is 4 over 5, we don't just double the ratio because we're doubling the angle, and that has some different implications. What we need to do is write down what that is. I'm going to use the cosine squared theta minus sine squared theta. You can use any of the other ones too, that's fine. Sine of 2 theta though, that's 2 sine theta cosine theta. And then the tangent of 2 theta, that's 2 tangent of theta all over 1 minus the tangent squared theta. If you want to derive these formulas, they all come from the sum formulas. It's just that this is a special case where it's theta plus theta, which is 2 theta, but you can use a sum formula here and you'll wind up with these. Alright, now we need to figure out what we know and what we need to know. Looks like we know the cosine, we need to know the sine, and also the tangent. So anywhere else, maybe right up here, you can draw yourself a reference angle, or you can just figure out x, y, and r. We're going to be doing that anyways. So here we've got some angle. It's x over r, so we can draw it maybe like this. And those are the axes here. There's our angle. This is 5. This is 4. Remember, that's a 3, 4, 5. So the x value is 4. The y value is 3, and r is 5. Let's work with the left one, cosine of 2 theta. That's cosine squared, so the ratio is 4 over 5, and we want to square that, minus sine squared. Sine would be 3 over 5, and of course that's squared. Now we've just got some arithmetic to do. 16 over 25 minus 9 over 25. Looks like we have a common denominator, good for us. So this will be 7 over 25. You could definitely utilize your calculator to check this by taking the inverse cosine of 4 over 5, getting an angle and doubling it. And hey, let's actually try that so that you can see how this works. So I'm going to make sure that I'm in the right mode. I'm in degree mode, so that's good. I'm going to type in the inverse cosine of 4 divided by 5, hit enter. We need to double it, and then take the cosine of that angle. So it should be 0.28. If we do 7 divided by 25, we also get 0.28. So it's interesting that you could do this one in your calculator, but if you have any radicals in there, any radical of a non-perfect square, your calculator is going to only give you an approximation. So this one worked out, but you definitely want to know how to go through these different steps. Let's try to figure out sine of 2 theta, which is 2 sine theta cosine theta. So sine theta we said was 3 over 5. That's utilizing the information we know. Cosine of theta we were given is 4 over 5. Remember, this 2 is 2 over 1. If it helps you, you can write an integer as over 1 to keep track of the numerator. So we've got 2 times 3, which is 6, times 4, which is 24. And then we've got 25 in the denominator, 1 times 5 times 5. On the right-hand side, we've got 2 times the tangent, and the tangent is y over x, or 3 over 4. If you use your reference triangle, it's still opposite over adjacent. You get the same thing. Over 1 minus 3 over 4 squared. This one, we're gonna make sure that we figure this out, and I apologize for the sniffles. I'm a little bit sick here. So 2 over 4 is just 2, so that's 3 over 2. Over, I know my denominator is going to be 16, so I'm going to change that 1 to 16 over 16 right away, and this is going to be 9 over 16. That's 3 over 2 over 16 minus 9 is 7, and then we've got a 16, so we're going to multiply by the reciprocal now, 16 over 7. This 2 and this 16 can be reduced, so we've got 8 times 3, 24 over 7. And that's the tangent of double that angle. And again, if you wanted to, you could double check your work. Remember that double that angle is about 73.7. So we could just take the tangent of 73.7, hit enter, and type in 24 divided by 7. And we get approximately the same value. It's off a little bit because we rounded the angle measure. If you wanted to figure it out more precisely, you could just do the inverse cosine of 4 divided by 5, double it, take the tangent of that angle. I use my second answer button, and then I could do 24 divided by 7, and you can see now we have the exact same thing. Either way is okay.